Hello students, today we will be solving the IB Math AAHL May 2025 paper 1 time zone 2 question number 11. You will be getting the solutions for the first 10 questions from this paper and the solutions for the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I am an online IB Math AAHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve the question number 11. The maximum mark is 17. Subpart A is saying find the first 4 terms in the binomial expansion of square root of 1 plus 5x in ascending powers of x. And this is the formula that is given in your formula booklet. And A over here, A has been assumed to be some other number not equal to 1. But over here, it is 1. Let us first of all rewrite this expression. Square root of 1 plus 5x can be written as 1 plus 5x whole raised to the power of half. Okay, this half is equal to n, which is a rational number. Okay, and since a is equal to 1, you don't have to pay attention to a to the power of n. The changed formula will be 1 plus, let me just rewrite this. If it is 1 plus bx raised to the power of n, where n is a rational number, then this is equal to 1 plus n times bx plus n times n minus 1 over factorial 2 bx whole square. Since they have asked up to 4 terms, let me write the 4th term also. Plus n times n minus 1 times n minus 2 over factorial 3 bx whole cubed and plus dot dot dot. Okay, so we will be using this formula over here. So this will be equal to 1 plus n is half in this case. So half and bx is 5x. Half times 5x plus n times n minus 1 over factorial 2. So it is half times half minus 1 over factorial 2 times bx whole square. So 5x whole square plus half n times n minus 1 times n minus 2. So half times half minus 1 times half minus 2 over factorial 3. 5x whole cube plus dot dot dot. Okay. So this is equal to 1 plus 5 over 2x. And this is half, and half minus 1 is negative half. So half times negative half is negative 1 over 4. And divided by 2 is negative 1 over 8. Okay. So in the denominator it will be 8. And in the numerator we are having 5 squares. So it is 25. Minus 25 over 8 x squared. The 4th term, half times half minus 1, that is negative 1 over negative half. So half times negative half is negative 1 over 4. And half times half minus 2. Half minus 2 is negative 1 and a half. That is negative 3 over 2. So negative 3 over 2 times negative 1 over 4. If I do this multiplication over here, negative 3 over 2 times negative 1 over 4 is equal to 3 over 8. Okay, so 3 over 8 and the denominator is 3 factorial, which is 6. So multiplied by 1 over 6, and these two will be getting cancelled. So we have 1 over 16. That means we are having 16 in the denominator plus 16 in the denominator. And what is the numerator? 5 cube is 5 times 5 is 25. 25 times 3 is 25 times 5 is 125. So it is 125 x cube and plus dot dot dot. Okay, so this is the answer. Consider the expression 1 plus px times 1 plus qx to the power of negative 1, where p and q are rational numbers. So part B's question is find the expansion of 1 plus px times 1 plus qx raised to the power of negative 1 in ascending powers of x up to and including the term in x square. Okay, so 1 plus px, it is a binomial, it is not getting raised to any power, so it stays as it is. This part will get expanded. Okay, for this we have to use the binomial theorem. Fine. So 1 plus px times 1 plus qx raised to the power of negative 1. Again, you are having 1 as the first term, so we can apply this formula, and in this case is negative 1. Again a rational number. Okay, so this is equal to 1 plus px and first term is 1 plus n times bx. So n is negative 1 times bx is qx plus negative 1 times n minus 1. So negative 1 minus 1 over factorial 2 and bx whole square, so qx whole square plus dot dot dot. Okay, so we are having this, and I do not want to take any other term. I have taken only the first three terms because they have asked us to get the terms up to x square, so this is x square. The next term will be x cube, so I do not need that. And now I can multiply 1 with these three terms and then again px with these three terms. I'll be getting a total of 6 terms. But let me see whether I need all of them. Definitely I will not be needing the term which will be found using by multiplying px with this one, because this will be x square and this will be x. So that will be x cube. I'll not be needing that term. So I'll be writing those terms which will be needed. So 1 times 1 is 1 and this one is negative qx. So 1 times negative qx is negative qx and this one is negative 1 and negative 2. It is equal to, or else let me just simplify this one and then let me do the multiplication. Okay, so it is 1 plus px 1 minus qx, and this is negative 2. Negative 2 times negative 1 is positive 2. Positive 2 and 2 factorial is 2. So 2 divided by 2 is 1. So it is plus q square x square and plus dot dot dot. So now we can do the multiplication. So 1 times 1 is 1 times negative qx is negative qx, 1 times q square x square is plus q square x square, then px times 1 is px, px times negative qx is minus pq x square, and as I had said, I'll not be requiring this term, it will be having x cube, so I'm writing plus dot dot dot. Okay, so this is equal to 1, and then I am grouping the like terms. It is minus qx and plus px. So I can write this as plus p minus q x, and then again for q square, let me take plus. So q square minus pq x square plus dot dot dot. Okay. The expansions found in parts A and B are identical up to the first three terms for a value of P and a value of Q. So part C's question is show that Q equal to 5 over 4. So they are identical. That means 1 plus 5 over 2x minus 25 over 8x square is equal to 1 plus P minus Qx plus Q square minus PQ x square. Okay. And of course, 1 and 1, they are the same. And we will be equating the other two terms. Okay. So let this be C. It is 1 plus 5 over 2x and minus 25 over 8x square is equal to 1 plus P minus Q x plus Q square minus PQ x square. Okay. So therefore 5 over 2x is equal to P minus Qx implies P minus Q is equal to 5 over 2. This is one of the equations. And the second equation is negative 25 over 8x square is equal to, let me also have a negative sign in front so that I can cancel the two negative signs. So I can write this as negative PQ minus Q square x square. Okay, so that I can cancel these two. So therefore, PQ minus Q square is equal to 25 over 8. This is the equation number 2, and I can take out the common factor Q, and I am having P minus Q equal to 25 over 8. And P minus Q is equal to 5 over 2. Okay. So therefore, Q times 5 over 2 equal to 25 over 8 from equation 1. Okay. So therefore, Q is equal to 25 over 8 times 2 over 5. So this is 4 and this is 5. So therefore, Q is equal to 5 over 4. Okay. So show that this. So it is shown. Fine. So part D, the expression 1 plus px over 1 plus qx, this is same as 1 plus px times 1 plus qx raised to the power of negative 1. Okay, this one and this one, they are exactly the same. With p value as 15 over 4, you can see q value as 5 over 4. You see, if you use q value as 5 over 4, let us check what is the p value. We have seen p minus q is equal to 5 over 2. Okay, so let us find the p value. Let us see the value that they have given, whether we can find the same value or not. So p minus q is equal to 5 over 2. So therefore p is equal to 5 over 2 plus q, so plus 5 over 4. So p is equal to 10 over 4 plus 5 over 4, which is equal to 15 over 4. Okay, so when q is equal to 5 over 4, the p's value is 15 over 4. This is nothing different. P is equal to 15 over 4 and q is equal to 5 over 4 can be used. The expression is this, with p value as 15 over 4 and q value as 5 over 4 can be used as an approximation for the square root of 1 plus 5x, where the absolute value of x is less than 1 over 5. Now D is having two further subparts. Subpart I is saying, hence, by finding a suitable value of x, find the approximation of for square root of 1.2 in the form of the m over n, where m and n are integers. Okay, we have one square root of 1 plus 5x and we have to get square root of 1.2. So let us solve over here. Okay, di and 1 plus px times 1 plus qx raised to the power of negative 1, which is equal to 1 plus px over 1 plus qx is equal to this. I'm not sure whether I'll be needing this one. Let's see. Okay, first of all, we have to relate these two, square root of 1 plus 5x and square root of 1.2. Okay, so square root of 1.2, in order to write this in this form, 1 plus something x or 5 times something rather x, the 5 should be staying, the x value should be determined. So it will be 1 plus 5 times something. So this is equal to square root of 1 plus, I can write this as 1 plus 0.2. Okay, 1.2 is 1 plus 0.2. So this is equal to square root of 1 plus 5x. Even if you cannot do this will be in fact simplifying the thing. Or else, even if you cannot write 1.2 as 1.0.2, doesn't matter, you just equate these two. Let me show you. 1.2 is equal to 1 plus 5x. I'm assuming that you cannot write 1.2 in this way, 1 plus 0.2, because this is absolutely possible, because this is question number 11. You may be running out of time, so you may not be able to think this. So 1.2 equal to 1 plus 5x, therefore 5x is equal to 1.2 minus 1, which is equal to 0.2. From here also I am getting 0.2 is equal to 5x. So therefore x is equal to 0.2 over 5, which is equal to 2 over 10 times 5, which is 1 over 25. You can write 2 over 50 or 1 over 25, anything. So x is equal to 2 over 50 or 1 over 25. They are asking us to find a suitable value of x, and we have found the value of x as 1 over 25. And let us see, they have given one condition, that this can be used as an approximation provided the absolute value of x is less than 1 over 5. And 1 over 25, 1 over 5, the numerator is 1 in both the cases. And this is 5 and this is 25. 25 is more than 5 and 25 is in the denominator. Therefore, 1 over 25 is less than 1 over 5. So therefore, this condition is valid for x equal to 1 over 25. Okay. So since we have found the value of x and we are required to find the value of square root of 1.2 in the form of m over n, I will be preferring this expression, not this expanded form where we are not having any denominator. Of course, we will be ultimately getting the denominator because this is having a denominator of 25. The p is having a denominator of 4, q is having a denominator of 4, but I want to use this expression 1 plus px over 1 plus qx. Okay, so therefore 1 plus px over 1 plus qx is equal to 1 plus p was equal to 15 over 4 and q was equal to 5 over 4. So 15 over 4 times x is 1 over 25 divided by 1 plus 5 over 4 times 1 over 25. Okay, so this one is 5 times 3 and 5 times 5. This is 5. So this is equal to 1 plus 3 over 20 divided by 1 plus 1 over 20. Okay, so this is equal to 1 is 20 over 20. So this is 20 plus 3 is 23 over 20. And this one will be equal to, this is again 20 over 20 plus 1, 21 over 20. So therefore, square root of 1.2 is approximately equal to, this can be written as 23 over 20 divided by 21 over 20 equal to 23 over 20 times 20 over 21. So it will be equal to 23 over 21. Okay. M and m divided by n and m and n are integers. Okay. So part I now consider the approximation for square root of 5 over 2. Approximation for this has to be because square root of 5 is an irrational number. Okay. Explain why the approximation for square root of 5 over 2 is not as accurate as the approximation for square root of 1.2. Okay. And they have said can be used as an approximation where this is the condition. This condition has to get satisfied. The absolute value of x should be less than 1 over 5. Only then can this be used as an approximation, as an accurate approximation. Okay. And so we have to show that the x value that we get for this is not within this range. The absolute value of x is not less than 1 over 5. Okay. So let's see. So d I, the number is root 5 over 2. The condition given is absolute value of x should be less than 1 over 5. And the expression that we were using was square root of 1 plus 5x. We have to find the value of x so that, and we have to check whether this condition is getting satisfied or not. Okay. Now this root 5 over 2, I can write this half is not within the square root and I do not want to take the half within the square root because half doesn't have any uncertainty. Half is always 0.5. But root 5, square root of 5, this is an irrational number. So its decimal equivalent will be, it will be an unending decimal number without any repetitions. So there comes the approximation, because we cannot take every digit of the decimal number. We have to take 3 digit, 5 digit, 7 digit. We have to stop somewhere. So there comes the approximation questions. So I will be taking only this one. So let me write my logic. Since half has no uncertainty, not uncertainty, or okay, uncertainty in its value, it is always half or 0.5. Therefore, or comma and then this, therefore, we take only square root of 5, which is an irrational number. Okay. So now we will be writing this 5 in this form. 1 plus 5x. Okay. So therefore, root 5 is equal to root 1 plus 5x. Now, and we have to find the value of x. So therefore, 5 is equal to 1 plus 5x, or 5x is equal to 4, implies x is equal to 4 over 5, which is more than 1.5, 1 over 5. For the approximation to be accurate, the condition that has to get satisfied is the absolute value of x. It is 4 over 5 is a positive number, so I'm not writing any absolute value. It should be 1 over less than 1 over 5. But 4 over 5 is greater than 1 over 5. Therefore, square root of 5 over 2 cannot be the value of cannot be found or approximated accurately using one plus px over 1 plus qx. Okay. So we have given the reason for why it is not as accurate as square root of 1.2. So we have completed answering this question number 11. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. In our next session, we solve the last question of this paper, that is the question number 12. Till then, bye.